Hi, my name is Chloe Winston, and I'll be presenting our research on nearest neighbor radiomics for self-supervised chest X-ray pneumonia identification. Identification of diseases from medical images such as chest X-rays or brain images is typically done by domain expert radiologists who will analyze and draw conclusions from the images. For example, a radiologist may analyze chest X-rays to diagnose pneumonia. To improve the consistency and accuracy of human interpretations of medical images, deep learning has been increasingly explored in medical imaging applications like this. However, supervised training of such deep learning networks requires large amounts of label training data, which may not be available. Outside of medical imaging, numerous self-supervised learning techniques have been developed to reduce the amount of training data required. In many of these methods, a model is encouraged to represent images in a positive pair similarly, where a positive pair is a pair of images expected to share the same label. SimCLR and SimCM use different methods of transformations to define positive pairs, and NNCLR defines positive pairs as two distinct but similar images in the dataset. The question is, can these methods be applied to applications like chest X-ray pneumonia identification? Unfortunately, typical image transformation methods may alter the meaning of a medical image. Furthermore, images of the same tissue from different perspectives can yield a false negative pair that look different but represent the same tissue. So how can we define positive pairs in a medical imaging application so that we can exploit the robustness of contrastive learning? We propose the use of radiomics, which are a low-dimension set of features that can represent a medical image. We hypothesize that images with similar radiomics are more likely to share the same label. Specifically, we propose an approach that uses supervised pre-training, then a self-supervised pre-training step, now using positive pairs defined through nearest neighbor radiomics, and finally supervised fine-tuning. First, we pre-train the backbone on a large natural image dataset. Next, we extract radiomics features from each input using the open-source PyRadiomics package. This results in a one-dimensional tensor with length 94 for each image. The nearest neighbors algorithm is then performed on these features across images to identify the nearest neighbors for each image in the radiomics feature space. We then applied an existing self-supervised learning algorithm, SimCM, but for each image, instead of performing random transformations to create a positive pair, we use the nearest neighbor of that image in the radiomics feature space. After this pre-training step, we fine-tune the classifier head on the label training data. We used a binary pneumonia identification dataset to answer 3 research questions to understand the performance of our algorithm. First, we analyzed the ground truth labels of the positive pairs and found that around 86% of positive pairs share the same label, and further, around 66% of those with pneumonia share the same type, that is bacterial versus viral pneumonia. This demonstrates that radiomics features do capture meaningful similarities and differences in the chest X-rays. Next, we compared self-supervised pre-training with positive pairs being the nearest in the radiomic space to that with positive pairs selected randomly. We found that positive pairs identified through first-order nearest neighbors radiomics boosted the F1 score. Thirdly, we conducted an ablation on the nearness, where the nth nearest radiomics pairs are used for self-supervised learning. The results demonstrate that accuracy degrades as the positive pairs used are farther apart in radiomics space. There are many avenues of future work, such as expanding this research to other chest X-ray classification tests, such as COVID-19 diagnosis, and even other medical imaging domains. In conclusion, We explored nearest neighbor radiomics, which boosted accuracy significantly for pneumonia identification. Therefore, we believe it is a promising approach for self-supervised chest X-ray machine learning. Please check out our paper for more details. Thank you.